All right. Good afternoon or good morning, whatever it is. NYP Biology. Today we are talking about translation. So we're gonna go through some notes right now. Get yourself ready right now. So, a couple things before we start. You should probably have something to write on, so you can write down notes. Remember, highlighted stuff you're gonna want to get down in your notes. Probably gonna want to have something to write with. All right, maybe a little a pen or a pencil. All right, get yourself distraction free. You got the little phones, the little things, whatever that are flashing and beep. Maybe you want to set those aside so you can just look at my face. And what else do I need to do? I think that's about it. You might want the codon chart and the sheet we're going to work on towards the end. About halfway through, we're going to start working on that. Not even halfway. Towards the end, we're going to look at that. So if you have that in front of you, you can break that out too. All right, but otherwise, we're set. Let's get started. So, talking translation today. Let's go. Review from last time. Can we fill this in? If we go from DNA to mRNA, that's transcription. That's what we did last class. So, basically, it's the same as going and making a complementary DNA base pair, except we're swapping T's for U's. There are no U's, or there are no T's in our DNA. Sorry, there's a bug in front of me. There are no U's in DNA, there are U's in RNA instead of T's. So let's do this. So if we see a T in DNA, what are we going to put across from that? We are going to put an A. And if there's an A in DNA, mRNA is going to have a U. And if there's a T, then we're going to put ourselves an A across from it. And a C, we're going to put a G across from it. G, we're going to put a C across from it. And we're going to keep on going like that. So keep going. Oh my goodness, another pop quiz question. Wow. It's like my test questions just leaked their way into the notes. What are two major differences between DNA and RNA? Pause, think. Good ones to think about. I bet you already thought of these. DNA is double-stranded, D double-stranded. RNA is single-stranded. DNA contains the nucleic or the nucleotide with a nitrogen base T, where RNA contains a nucleotide with the nitrogen base of U. Our DNA has got itself deoxyribose sugar, where RNA has ribose as its sugar. Fun. We talked about this last class, central dogma. So DNA goes to RNA. That beautiful animation right there. Yeah, you see it. That's what we did last class. Now we've got RNA. So now we got to talk about translation going from RNA to protein. So that's what we got to do. All right. If you don't like the words I just said, check this out in visual form. Last class we talked about transcription, and today we're going to talk about translation. All right. So let's do this. All right. Different types of RNA. All right. We showed this last time, didn't we? There's 3 different types of RNA. Probably wrote down the mRNA. All right. If you didn't, now's your chance. Let's also write down tRNA and rRNA. Last class, we were talking about transcription. It's all about getting that mRNA. But now we're going to start looking at translation, which is going to bring tRNA and rRNA. So take a moment, write those down, pause me. All right, I'm back. You unpause me. So we got that. What else do we need to know? Ooh, codons. Codons are sets of 3 RNA nucleotides on an mRNA that code for an amino acid. Look at that right there. So it's just 3 of those. So ACE or UCA, that's a codon. Anytime we have a set of 3 on our mRNA, that's important because watch what I'm about to show you, tRNA. So the anticodon is found on the tRNA. Check that out. So it's still 3. But instead of it being on the mRNA, it's on the tRNA. Here's an interesting thing. If we look, the anticodon kind of looks like it would fit with the mRNA, the codon, if it's in just the right order. I bet it would fit. Let's keep that in mind as we go into this next one. And finally, amino acid. All right, the amino acid. Oh no, how can I move my head? Can I move my head? Oh, look at that. going to shrink it for a second. So amino acid, a monomer of a protein. It's carried to the mRNA by the tRNA. Again, reminder from Unit 2, reminder from last class, reminder from the class before that. You're made up of proteins. Proteins are very important. And proteins are just long chains of amino acids. All right. So we got that. Oh my goodness. Read my mom. What are amino acids? So amino acids are the monomers that link together to form proteins. There are 21 different amino acids. They're produced by our liver or our diet. All right, essential amino acids that we're going to be getting from our diet. A lot of those, followed by a lot that you can produce. So these are the things, though. They are the monomer or the building block, we could call it, or the subunit, whatever we want to call it, that make up protein. All right, just make my head bigger if I go like this. Woo. Let's see if it changes it back. All right. Again, pause me. Write all this down. I'm paused. All right, let's unpause now. Amino acids. All right. Now it's a big part. Translation. So, give you a second to write this down. Pause me again. All right, unpause me now. So, purpose. Why do we do translation? We want to carry protein. All right. We want to carry the instructions now. We've gotten them out of the nucleus. That was transcription. Transcription made the mRNA, took the code from the DNA that was housed in our nucleus. We got it out now. So now translation, we're actually going to take that code from the mRNA and actually make the protein. All right. This is going to happen at a ribosome. We're going to start with that mRNA we got from transcription, and by the end, we're going to have protein. It doesn't turn into protein, but it's kind of the starting thing and the ending thing. All right, so steps. Get yourself ready. I got 5. 1 and 2 right here. mRNA attaches to a ribosome. Ribosomes. Start reading it. All right, so I was going to start at the start codon. All right, we're looking at AUG. Oh no, I went too fast. Pause me. Unpause me. Part 3. tRNA molecules come in. This one's exciting. I have an animation. So let's look at the one down here. So start codon. I see an A, I see a U, I see a G. All right, that's our start codon. So what's going to happen? We're going to find the anticodon. So if AUG is the codon, the anticodon would be UAC. So that little tRNA is going to come in and it's going to match up. And attached to the top of it is that little amino acid up there, and it's just going to keep happening. All right, these little tRNA guys are going to keep on coming in. Look at that. All right, going to keep popping in. All right, now here's where the protein actually comes in. All right, they're going to start bonding. Those amino acids are going to bond together. All right, and that chain is going to be the protein. All right, it's going to continue on until it hits a stop codon. All right, there are 3 stop codons. All right, we'll see a little more about actually decoding those in just a moment. All right, again, pause me. All right, let's do codons. So there are different codon charts we can use. There's a wheel and there's a chart that we can use. Both will do the exact same thing, but we can take a codon and we can figure out what that actually means or what it stands for. So let's do that. I personally like the wheel. Wheels are fun. Shapes are fun. So we're going to look at this. All right. Let's pretend right now we are trying to figure out AUG. That's our start codon that we're going to be looking at in these. So let's try and figure that out. Here's what I want you to do. Look at my screen. Put your little finger on the A. All right. We are decoding AUG. That's our codon. We're going to figure it out. So put your little finger on the A. Now slide it down to the U. All right. And now slide it again to the G. You're working your way out. All right. You don't want to stay in the middle. You want to work your way out. All right. Once you get it on the G, you should be in a little wedge that says methionine. All right. That is the amino acid that AUG codes for. All right. So give it a try. Check it out. You can kind of see it. It's like middle and it just works its way down. All right. You'll notice sometimes there are multiple codons that code for the same thing. So AUA codes for isoleucine, along with AUC and AUU. All three of those code for the exact same amino acid. That's okay. It's not a bad thing. All right, that's normal. All right, so check that out. All right, you're going to be doing this today on our practice assignment. All right, so your practice assignment is going to look a little bit like this. All right, actually, it's going to look a little more like this. All right, so here's what you're going to do in the practice assignment. Some pre-questions on there. You'll see that pre-questions on there. Answer those, a little review. All right, so then on this assignment, what you're going to be doing, you're going to go from DNA to mRNA. That is transcription. That's what we did last class. All right, but then you're going to go from that mRNA to the amino acid. All right, that is translation. So that's the new one. So that's what you're going to use the codon chart for. All right, there are codon charts in the front of the room. They're in that basket. All right, please grab that, use it. All right, when you're done, if you could please put that back. We're trying to save a little paper. All right, so toss it back up there when you're done. All right, so we can share those with our other classes. All right, but that's what we're going to work on right now. All right, so here's what the plan is. Right now, practice with translation. All right, you've got it. Let's do it. All right, some translation practice. All right. Once you're done with that, I want you to do two things. I want you to take that note, these notes you just wrote down. Okay. Take those and take that translation practice and clip that in your binder. All right, save it. We got a binder check next week. And then here's what we're going to do for the rest of the time. We have that little Explore Learning online model we did with mitosis. All right. As I just said, binder check's going to be next week. So I want you to make sure that that is complete. This is your time to do it. All right. I don't want to hear next week that we didn't have time to do it. All right. Because you got time right now. I'm watching you. All right. I'm always watching you. You see me. All right. Let's get it done. All right. So 2 things. Translation practice in your notes. Clip them out. Save them. Second, let's finish the Explore Learning Mitosis sheet we did last class. Or what was that, 2 classes ago, 3 classes ago? All right. If you have any questions, let me know. Send me an email. All right. I'm here for you. Otherwise, please let whoever's in the room know as well. All right. Thank you so much. Have a great rest of your day. I'll see you in a little bit.